Welcome to True Projects. In this video, we are going to explain about the project, which is Automatic Severity Classification of Diabetic Retinopathy based on DenseNet and CBAM. Introduction. Diabetic retinopathy, a complication resulting from elevated blood glucose levels, is considered one of the most serious threats to vision. Unfortunately, the current method of DR screening relies on manual assessment by ophthalmologists, a process prone to errors and time constraints. This project revolves around automating the severity classification of diabetic retinopathy, a critical complication associated with diabetics. DR is known to cause vision impairment and blindness in affected individuals. In this context, the project seeks to leverage advanced technology to assist in the early detection and classification of DR. By developing an automated system to classify DR severity, we focus on using DenseNet and CBAM models to accurate results. By automating DR severity classification, this project can have a profound impact on healthcare. It will provide healthcare professionals with a faster and more consistent tool for diagnosing and tracking the progression of DR. Early detection and accurate classification will lead to timely treatment, ultimately helping to preserve the vision of individuals affected by diabetes. Coming to objective, the primary goal of this project is to develop an automated system that can classify the severity of diabetic retinopathy using advanced machine learning models, specifically DenseNet and CBAM. These algorithms can enhance the efficiency and accuracy of DR diagnosis. DenseNet and CBAM enable robust feature extraction and attention mechanisms for precise severity classification. MobileNet, if proven effective, can offer a more efficient alternative for accurate DR classification. The ultimate goal of this project is to provide healthcare professionals with a reliable automated tool that accelerates the diagnosis of DR severity. By achieving this, it aims to facilitate timely medical interventions, thus reducing vision loss among diabetic patients and improving their overall quality of life. For implementing this project, we need hardware and software requirements. Coming to hardware requirements, operating system of Windows, processor of 5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above are required. In software, we need Anaconda 3 and Visual Studio Community version. We have designed few modules in the flow of work to implement the project. The first one is importing the packages. This module involves importing the necessary libraries and packages. NumPy is imported for numerical operations, Pandas for data manipulation, TensorFlow for deep learning, Matplotlib and Seaborn for visualizations, and Scikit-learn for machine learning. Exploring the dataset. In this step, we investigate the dataset containing processed images related to diabetic retinopathy. This exploration helps us to understand the data structure, distribution, and characteristics which are crucial for the subsequent analysis. Image processing using image data augmentation with Keras as a backend. This module involves employing Keras as a backend to perform image data augmentation. Data augmentation techniques are applied to the images to increase the diversity of the dataset and improve model generalization. Data extraction to train and test. In this step, the dataset is divided into two subsets, which are training set and a testing set. The training data is used to train the machine learning models, while the testing data is reserved for evaluating their performance. Model building. In this step, we build multiple models, which are Inception V3. It is constructed for a deep convolutional network architecture known for its effectiveness and image classification task. MobileNet. Here we build the MobileNet model, which is optimized for efficiency, and it is evaluated for its accuracy in classifying diabetic retinopathy severity. Baseline DenseNet 169. Here we create the baseline DenseNet 169 model, which serves as a reference point for comparing the performance of other models. DenseNet 169 layer with CBAM. This step involves adding a convolutional block addition module, which is CBAM, to the DenseNet 169 architecture to enhance feature selection and improve classification. DenseNet 169 with CBAM and with INS. In this module, the DenseNet 169 model is further augmented with CBAM, an instance normalization technique to optimize its performance for diabetic retinopathy classification. Training the model with train and test. Here we train the constructed models using the training data while validating their performance on the test data. This step involves adjusting the model's parameters to optimize its ability to classify diabetic retinopathy severity accurately. Building the model. This module focuses on assembling the machine learning models and configuring their layers and defining the model architecture. Flask framework with SQLite for sign up and sign in. In this step, we set up a Flask web application framework with integrated SQLite database to facilitate user registration and authentication. This enables users to access their prediction functionality. User gives input. User interact with the web application by providing input, typically in the form of an image related to diabetic retinopathy. Input pre-processing for prediction. The given input by the user is pre-processed to make it suitable for model prediction. This involves data transformation and formatting to align with the model's requirements. Trained model is used for prediction for about image. The trained machine learning model is employed to predict information about the provided image. Specifically, it is diabetic retinopathy severity classification. Final outcome is displayed through front-end. The results of the prediction, such as severity classification of diabetic retinopathy, are displayed to the user through the web application's front-end, providing valuable information and insights based on the input image. For execution, we need to open the code folder which contains the source code files. This is the static folder. This folder consists of the files related to CSS, JavaScript and Bootstrap files. This is the templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, which represent different pages of the website. This is the app.py file. This file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content that to be rendered in the HTML templates. And this is the notebook.ipynb file. This is the Jupyter notebook file which contains a combination of code, graphs and outputs all in one place. And this is the sign-up file. This file is a database file used to store the user information. Now we need to copy the path of the code folder from the address bar of the file explorer. So we will copy this and open Anaconda prompt. Using the cd command followed by the space, we need to paste the copied path. This command is used to change the current directory to the code folder's path. Now we will click on enter. So the current directory is changed to the code folder's path. Here we will type python space app.py. This will compile app.py file, and this command will execute the Python script and perform a runtime check for any syntax errors or logical issues. Now we will click on enter. After running the app.py file, the Flask framework will host the application locally at the default address, which is localhost and the port number unless configured differently. And this is the localhost and this is the port number. Now we will copy this local link provided by the framework and paste it in any browser. We will paste it in the Google Chrome. Here we'll paste the link and click on enter. It has redirected to the web page which is displayed in the browser. And this web page is developed by using the Flask framework. Now we will click on sign up. We need to fill all these registration details if we are registering newly. I have already registered, so I'll directly click on sign in. Here I need to provide my credentials, which are my username and the password. By providing this, we will be logged in. Now we will click on login. So here we need to upload the image. For that we will have the predictions. Now we will upload an image. So we will upload this first image and click on open. Now we will upload it. So based on the given image, it is predicted that the patient is detected with mild diabetic retinopathy. Now we will upload another image. We will upload this and click on open. Now we will click on upload. It is predicted that the patient is detected with proliferative diabetic retinopathy. Now we'll upload one more image. We'll upload this fourth image and click on open. Now we'll upload it. So based on the given input, it is predicted that the patient is detected with proliferative diabetic retinopathy. Now we will upload one more image. We'll upload this image and click on open. It is predicted that the patient is detected with no diabetic retinopathy. In this way, we can upload any images which is having the disease. For that, we will get the prediction whether the person has disease or not. Now we will sign out. The inclusion of MobileNet as an extension allowed us to explore alternative approaches for DR classification. While further research is needed, it highlights our commitment to finding the most efficient and accurate model. The automation of DR severity classification holds significant clinical implications. It offers healthcare professionals as a faster and consistent tool for diagnosis, enabling timely interventions and ultimately the preservation of vision among the diabetic patients. As the field of machine learning and medical image continues to evolve, there is room for the further improvements and optimizations. Future directions may involve in the integration for more extensive datasets, fine-tuning of the model, and ongoing research into the emerging algorithms.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.